sixth video of this lecture series. So let's get started. Whatever we discussed in the previous sections about those things, data, data resource, how you can handle the data, how to modify the data, how you take the data in XML file, how to recognize which one is the input data set, output data set along with that. So there I forgot to mention some one of the about things in the about the regarding data. That is okay, yeah. That is about the data of data forms. In the data form as well as it is all the numeric type data sets. That's why it is takes as a number. If you want to change your data set, you can type SL to structure, integer to structure, matrix to structures, type of data set, table to array, cell to array. This many data sets. But you should have to recognize these those data set which data set is suitable for you into which domains. You should have to know these things. If any data sets is contained a number as well as alphabet, so num to characters or numeric characters, you should have to choose. Structure type of data set you should have to choose. Table to array type of data set you can choose. If the data set is only content, instead of number only the alphabet is value, then you can choose other type of data that other type of the structure type of data you can choose. So okay, so by this way you can choose the number of data types. Now in these sections I will discuss about the neural network data training, how you can train the data in the neural networks. Before that, I would request you, those of the participants that new these domains, please to watch the video from the very first in this lecture series to get the to build the complete idea about that. Here I will discuss about the how to train the data neural networks, and it will be your first video. It is a demonstrate demonstrate video. If you get the complete idea from this video, you are able to train any networks. Trust me, you are able to train any networks. So I will learn you in a very simple way, very simple way. So let's start. In this training procedures, what I will do, what we cover, I will cover the training. Create or import your input data for trains. After that, we will cover some training, create or target data. If you have it, it's no problem. You need to just import it. Another, you will need to create it. And after that, we will training the neural network. After that, I will training my own data as changing the default values. Okay, because if you train the data set with the predefined values, predefined training function, learning functions, a network is possible rather you can break the default values. You can propose to you, or you can write your own parametric values of the training functions. That is also possible. So after that, we'll calculate the error, how much errors we obtains, okay, in our data sets, which is not well performed as the target output, and we'll calculate the performance also, and we'll calculate the forward clock also. These cases. So let's get started. So I'm here. So it is the basic examples. Just whatever the blue lines, this is the commandment lines. Just forget about the blue lines. See, the data to training is only one line, two lines. It is the input line, target lines. It is the training lines, and it is the plot line. Thus, only how much? Like 10 line data, 10 line code is enough to train a neural networks. Trust me, train a neural network. 10 line code is enough for very basic part. Now, let me discuss the things. Here, there is a lots of things is here. There is a uncertainty. This workspace I don't want, so please clear the workspace first. So here, hold off, and okay, fine. Now I'm taking as the input data. That is called the input data. Okay, that is the input data, and this is one is the target data. Why target data? um, okay, input data. Input data is started from 1, it will go up to 100, where the increment is 1. I mean, it will takes 100 data, 101 data, because it starts from 0 and it will go to up to 100 and takes 1. I mean, the data will be input data 1 2 3 4 5 6 up to 100. Okay, and output data will be whatever the input data, output data will be its square value. Suppose input data is 2, so its output 4. Input data 3, its output 9. Input data 6, it output 36, like that. Okay, it's input data, output data we have created. So very first example. Now we need to train the data. How can train the data? In MATLAB, just this line is code enough to train the data. Named. Net means network. Network is equal to which network you are using? New FF. I am using here new feed forward networks. Inside the feed forward network, there is a default value. If you want to mention, you can. If you don't want to mention, that is not necessary. Where new feed forward network I'm using here. In the feed forward network, I'm mentioning in the bracket that X is my input data and Y is my output data, and 5 is the number of data layers. Understand? Please understand the situation. It is the my data about. Very basic. Suppose what is new feed forward data? If you want to learn, just go there and type array new feed forward. New feed forward is the new feed forward network, which is the number of default values. By using the default values, we are training the networks. Okay, we are not override with the previous training functions values. See, it is a new feed forward application networks where it will create these things. Okay, you write all the things, read all the things. So after that, we are using here net is equal to training. After that, we are training the network. How? We are training the network is net means here will take already input value, output value, hidden layers. We are training the networks, and the networks we have defined here. This X is the input value and this Y is the output value. So we have defined. Okay, this is the enough forming the networks. After that, obviously, after training, network will give me the some value. What will give? No, network X. Whatever the network X input, for X input, it will gives me the output in Y net. Okay, X net X, for net X values, network will give me the output value, and output value I'm storing here by using by the variable Y underscore net. After that, I'm trying to figure it out something like that. Name of figure one. Okay, figure one, that where I want to plot Y. I'm just plotting Y. Plot Y means I'm plotting the Y. Y is the output, actual target output. After that, I'm hold on. Hold on means I try to hold on the graph and override the graph again with the another plot, that plot Y net. Y net R. It will take the red lines. Okay. So in a plot in the figure one, I'm plotting the actual output and as well as my targeted output in figure 1. Okay, and actual, sorry, in the whatever the output we are getting after training, it will be comes in the red lines. Very fine. And we are calculating the error also. Obviously actual output and training output will not be same. If it is same, then your luck is very good, and it's not possible for every time 100% that actual output and training output will be coincide. It's not like that. So obviously there will be errors. So perfect value is target value, and target value we are subtracting the our value whatever we get after the training. So it will gives me the error, and I'm taking another figure of figure 2. In figure 2 I am plotting the error. Okay. This much code is enough for training the data. So let's run the code. Control S 5. Yeah, my data is training under procedure of training. Yeah, already my data is training. Have doubt? Any doubt? It is about the figure 2 and it is about the figure 1. In figure 1, it is coincide. I think it is coincide. This graph actually coincides. Okay, because there is a input line and output also, whatever the output get, this coincide like that. That's why we are getting to the plot, and it is about the error. First, see, our error is 0. First, it started from error, and the last error is going to be very high in the last positions. So let's see, discuss the things one by one. Here in the graph, by using this thing, we are getting the results. Now, if suppose I want to see what is the uh, networks? How's the network actually? Okay, what is the networks looks? What is the network I'm using here? Feed forward networks. How's the look of the networks? Let's see. Looking at the network, you can see from here. View that. If you give the command in the this box also, it is a networks size. Hidden layer is 5 neurons is uses. Now output layer, it is look like this. Okay, it is about the new networks. Okay, so if you want to view the network also, you can put the command here, these commands inside also, no problems. If you view the networks and put here also. So now I want to see what is the input value of particular something positions. So how can we see? Go to here and type this command. Okay, want to see what is the input of 10 10 position input. What is the 10 positions input? If you press enter, so the 10 positions input is 81 point something like that. And what is the output of 10 positions input? If you want to see the output of 10 positions input, net y, the actual output is will be this point, like this. The square value of this will be this. What is my net given to me after training? What is my net network given to me? My network is given output like this. My net it is given output me 100. Want these things. So obviously I have error something. Of course. What is the error of this my networks? How can I see? I can see an error with the command of uh, performance. Performance. Performance of the networks. Networks is net, comma, input and target. What is the input X? What is the target I used? So it will give me the performance. So the performance is like this. It is the my performance in the networks. Now I want to see the classifying the target object. How can you classify the target object? To classify the uh, target object, you write the command classes is equal to is equal to int. Okay, and type your target. It will evaluate the classifying of the target object. Our classifying target object is look like this. Okay, it is the basic concept of particle center. Neural network trainings. Now, in the neural network trainings, it is look like this. If I want to calculate the error, what is the error actually? The error you can calculate here. Error. What is the error? My actual output is 1. Why? Am I getting the targeted output? My evaluated output is here. So take this thing. This error will be like this. For each of the thing, my error is like this. And for each of the data, I have some error. Okay, it's maybe possible because it's not human perfection that your output, your performance will give the 100% accurate value. It's not like that. Okay, so the basic concepts. Now evaluate the code sections now. In case I'm using these things, if in the new feed forward network the default values is there, if I want my default values like this, so what will happen? Suppose now let me comment this thing. Yeah. Now I will want to use net.train params epoch 3000 epoch I will use, and goal the maximum optimum value will create 1 e to the power minus 25, and net parameters of LR. LR means the learning rate 0.01. We will take the learning rate to this I want to use. Now let's see the output again. I'm using a 5 and let's see the output. I think this type of output will be the output is quite good rather than before. Okay, rather than before output is good something, and it's the curve and it's the made inputs. I'm coming to the sections later. What is this? Okay, understand. Now in the new feed forward networks, instead of using like this, you can use your own network also. For that case, I'm uncomment these sections, comment these sections, and I'm uncomment this section. When I uncomment this section, what happened? Now net is going to new feed forward new feed forward networks minimized the maximum values of inputs. Okay, where 20 is the hidden in the networks and 1 is the targeted output where values. Okay, and in this case I'm using log sigmoid functions for training purely at the output sections. I'm calculating the evaluation with the purely functions and train LM training Leavenworth-Markov theorem using for training the networks. I'm repeat the statement again. Min max I want to evaluate the maximum values of minimum of maximum values of inputs with 20 hidden layers, but the targets 1, and you are using log sigmoid functions as activations functions, and pure lane is a output functions where output function we are calculating the output in pure lanes, and train element we are using training Leavenworth-Markov with back propagations to train the networks. To train the networks means feed forward networks. Okay, when I mentioned these parameter values, now train the networks again. Something is error is there. What is the error? Inputs, it's not find the inputs in line number 13. Go to the 13th and it is not find the inputs. What happens? Obviously it will not find. So instead of inputs used here X, I think now it will find. Now run the program, it will just be done. Now the program is successfully running. Yeah. This can be possible by changing its parameter values. Now if you want to see, it is a 20 hidden layers and only one in the output layer, only one. So we to the basic things about things. Now instead of using these datasets, I want to use my own dataset. So I'll comment the line here. I'll comment the line here. Okay. I will use my own dataset. What is my own dataset? My own dataset is here. Sorry. My own dataset is here. Let me describe the dataset with you. File name is browse console datasets. Browse console dataset is here. Browse console dataset here. This dataset. Okay. So here in this dataset, input data is in sheet 1, target data is in sheet 2, and input data in Excel sheet. It will take the input data from file name to input data from. It will go to the input data from A1 to I286, and target data same way. It will go to the file name and target data sheet, and it will take from 1 to A286 targets. And we need to transpose, and this sample is the transpose. We need to transpose the input in column wise, and we have transposed the target also in the column wise. Fine. Now we will train the data. Before that, we are using before training as a x, input data x and target data y. Here we need to modify. What is the x? Instead of that, we used inputs and inputs targets. Here is inputs in this one. It is my targets. Now I need this calculated for me, and I will change the y name. Okay, fine. Let the program. It is running successfully for the browse tensor datasets. It's amazing. Now I'm using browse tensor datasets. Let's see, the program is successfully running. I'm training the browse tensor dataset in neural network toolbox. In neural networks, till the data is running, see it is training the neural networks. Until any of the values is reached to here, it will be trained. So till now my program is training. Data is training because the data set is also very vast. Yeah, complete. In the figure, it will shows the input. It will be the actual 0000. This is for 0 lines for target, and this is for 1 lines for the targets. So my targeted training targeted is find like this one by red lines. Okay, and yeah, so then exactly, it is amazing. So I will tell you that I will use my own data, whatever I will create it in the first. And before that, let's see the at least one time with these data sets, cross function data set. Let's see whatever the data set I used here. I'm using this data set training. It is the input data sets. Let's see input data sets, and this is the target data sets. Okay. Now, whatever the data set I give you explanations before, I will try with that data sets. So my data set is banknote. Let me copy the data sets and come to here and put it here. Yes, copy the datasets. My dataset now here banknote datasets. Let open the datasets. Those of the are called instance. So how many instances there in my banknote datasets? There is a 1372 instances there, and each of the instance have four attributes: 1, 2, 3, 4 attributes. So 1372 instance is there for input and as well as output also. 1372. So it will be T 1372. 1372. Here it will be A 1372. This output is there. Dataset name will be changed. Dataset banknote, banknote data. All things right. Let's run the program. My program is running here. See, training is ongoing process. Training is an ongoing process. Okay. Yeah. Shit. Exact results. I also don't know. I getting the exact results for banknote data sets. See, it is a 0 for all the values and it is a 1 for all the values. It is a exact result for my results. Okay. Now, if you want to see the regressions, what is the regressions? Regressions, I'm coming to you. What's up? The regressions. In my banknote dataset, what is the trading function I'm using? Regression is 1. I mean, in the banknote dataset, I use the banknote dataset to train the neural networks and it gives me perfect results because here the dotted lines and the fit line is coincide with each other. That's why I use 1. I mean, the targeted data and actual training targeted data are both same. That's why it's get 100% perfect results for banknote dataset only. For other dataset, it will not give you the so super, I mean, so super extreme result. Will not give you sure. But banknote data is given to you the very exact result. So I think hopefully you learn how to data in your network frameworks, in your own data, how to extract data, how to modify the data, how you manage the data to train the neural networks. I think hopefully you understand. So please like my video, subscribe my channel, and press the bell icon for more and more updates. In the next sessions, I will show you how to train the data in neural network toolbox. Okay, it is also amazing parts. So don't miss the second part also of this video, how to train the data in neural network toolbox. So today this much. Thank you. Goodbye.